Alright, so in this first half then, we're going to be looking at the two main dating methods that scientists use in order to date certain things within the world, which they will then say proves the world must be very, very old. And we'll find exactly how old they say it is as we go through. In the second half, we'll then be looking at other evidences that they will put forward for an old Earth, and we'll be seeing just how much water those hold as well in the second half. And I particularly find those quite fascinating. I wanted to start with a couple of quotes. This first one, I only came across it this week actually, and it was from a newspaper, the Daily Telegraph, in February of this year. And this article was written by a gentleman or journalist called Rupert Myers. And this is because a Christian, whose name, if I just check here, is Dan Walker, and he got a job as a news presenter on BBC. And this guy was basically saying that no way should a Christian be a news presenter on the BBC. And the article was very much mocking him in many different ways, saying that he's meant to be a presenter of fact, and if he believes in things that are in the Bible, then obviously he's way off the mark. And this is one of the quotes from that article, and it says, "Creationism doesn't just deny Darwinian evolution, it denies the findings of astronomy and chemistry, the age of the universe, the scientific consensus that underpins carbon dating, and ice core samples over 500,000 years old." Now, by the end of this session, we'll have looked at everything he mentions in that claim there, and we'll see if what he's saying is true. But this very much mocking kind of attitude that we see today towards Christians who believe in creation was predicted in the Bible that this would happen. 2 Peter 3 verse 4. And if we start at verse 3 and move on to verse 4, "Know first of all that in the last days mockers will come with their mocking, following after their own lusts, and saying, 'Where is the promise of his coming? For ever since the fathers fell asleep, all continues just as it was from the beginning of creation.'" Highly, highly significant statement, because if we look at that, what that's saying, it's more or less saying everything's carried on as it always has. Nothing's ever changed right from the beginning, and therefore, nothing's ever going to change towards the end either. And we'll see how that kind of philosophy has filtered through into the scientific thinking as we go through. Okay, now, first thing to note is that rocks and fossils and other things that are looked at for dating, it could be things that were once organic, for example, things that were once living, they don't come with labels on them. They have to be observed in the present and then interpreted by what you can see in the present. You have to interpret the past through those. And that can present a few problems, because how do you interpret something that you can't actually see? So we'll see how that's done in a moment. But before we do that, we're going to have a look at something called lateral thinking. Has anyone heard of De Bono at all? Lateral thinking? He came up with this idea about the late 60s, and this book was published in the early 70s. And it was meant to be actually for business people. It's all about thinking outside the box, so looking at exactly the same data, but coming to different conclusions just by thinking about it slightly differently. So what we're going to do, just for a bit of fun at the beginning, is we're just going to do a couple of lateral thinking exercises to get you into this way of looking at things in a different way and not making assumptions. Right, so we're going to do the first one. I'll just introduce it. So if we look at this now, here is your scenario, all right? And imagine you're going to be doing some detective work. So Fred and Mary are lying dead on the floor of a bedroom. There's broken glass on the floor. There's water on the floor. The window is open and the curtains are blowing in the wind. And my question to you is, how did Fred and Mary die? So what I'd like you to do is to talk to the person next to you and see if you can work out how Fred and Mary died from that scenario. You can ask me questions, excuse me, and I can answer them at my discretion without giving away the true answer. So if you'd like to discuss that for a couple of minutes, and I'll give you the actual answer and see if you're making the right assumptions. Fred and Mary are goldfish. And the bowl blew off the windowsill by the curtains that were blowing in the wind. Now, some of you may have assumed that Fred and Mary were people.
Yeah.
Yeah? And that's what can lead you down the right track. So the assumption was the crux of the problem. Okay, we're going to do one more of these, and then we'll move on to more scientific methods. Right, here's another one, completely different now. Right, so have a look at this. There are 6 eggs in the basket. 6 people each take 1 egg. How can it be that 1 egg is left in the basket? The 6th person took the egg and the basket.
Yeah.
Okay, perfect. Well done. Now then, we're going to start to get into the mode of thinking like the scientists do now when they're dating something. And to do this, I'm going to teach you a little parable. We all know what a parable is. Jesus taught in parables. And this one is from a book called by John Morris called The Young Earth, which if you're very interested in this topic, I would highly recommend you read. So this is the scenario. Imagine you walked in here today and there was a guy up here, lecturer, and he's got a table, potato basket on it, and he's peeling potatoes. So you come in and sit down and you watch him peeling potatoes. So you observe what's currently going on, and you can see potatoes being peeled and being dropped into the basket. Then you notice that every time you're looking at the clock, every time the second hand hits the 12 at the top, he's dropping another potato in the basket. And you observe him for 10 minutes. And you note that the rate of peeling is 1 a minute. Because every time it hits 12, it drops another one in, and you observe that for 10 minutes. After a while then, you start to think, I wonder how long that bloke has been doing that. So the first thing you do is go and have a look at how many potatoes are then in the basket. And you observe that there are 35 potatoes in the basket. So based on your assumption then, you look at it and you think, okay, the rate of potato peeling is 1 per minute. There are 35 potatoes in the basket. So I deduct then, or I assume then, that the process has been operating for 35 minutes. And that's how long the whole process has been going for. Right, but you had to make some assumptions in order to do that. So the first assumption you're making, whether you know it or not, is that potato rate, the peeling rate, has remained constant throughout the whole history of the potato peeling. Which is a big assumption to be making. Because how do you know that the guy isn't actually getting better at it? Has he speeded up? So he speeded up to be doing 1 a minute. He started off very slow because he'd never really done it before. Alternatively, he might be slowing down. Perhaps he started off really quick and he was doing 2 a minute. And then he's getting tired and he's cut his finger and all of a sudden he's slowing down. So now he's only doing 1 a minute. You don't know that unless you've actually seen him do it. The second assumption you're making is that no potatoes are being taken away or added to the basket. And that's what's called a closed system. If it's a closed system, there's nothing affecting it from the outside. You don't know that. How do we know? While he was peeling the potatoes, Auntie Yvonne comes along and takes 10 out because she thinks she'll cook them for the lunch. Right? I think I could do with those. And how do you know that somebody didn't come and put some in? So maybe somebody came along and said, oh, you look a bit tired. I've done some at home already. Have 20. There you go. And so the basket started off with 20 in it. How do you know the guy didn't do some at home himself? Bring them in, put the basket on the table, and there are already 8 or 10 in there already. All right, so that's the second assumption you're making. All right, that there's been nothing interfering. And the third assumption you're making is just that it started off with no potatoes in the basket. So that's what we call a nil ratio. So there was nothing in the basket to start with. Basically, you've got no basis to assume any of those things unless had you been there and observed the process from the start of the potato peeling to the end, you've got no way of assuming any of those things. And if one of those assumptions is off, one of those assumptions is wrong, it can massively affect the conclusion that you come to. Right, now I'm going to look at a real life example. Now, there was a guy called Charles Lyell. I mentioned him last time. He's the gentleman who wrote the book Principles of Geology that Charles Darwin took with him on his trip around the world on the HMS Beagle. And it planted the idea of long time frames in Darwin's mind. And he came along and he wrote that book, And there was a guy before him called James Hutton as well, who started to look at things, how they were operating in the present, and came up with the saying, the present is the key to the past. So you look at how the rate of things operating currently, and then you calculate backwards, extrapolate back to work out how old things are. And that's called uniformity, and it's basically the foundation of everything in science. So in space, everywhere, all their calculations are based on uniformity. And they will also tell you that the way the Big Bang happened, the way things happened after the Big Bang, set that kind of precedent for the foundation of uniformity then. They will tell you that. So it's been operating all the way through history. Things have never changed from the start, and have never changed towards the end as well. Did we just read something similar to that in the Bible, what people are going to say? We did, all right? So it was that whole thing. Things have never changed. Things are never going to change in the future as well. It does say in the Bible as well that things have never changed since the start of creation. And then since the Big Bang Theory came along, they did accept then there must have been a start. They were very resistant to that to begin with, because they thought that sounds like there's a beginning, which sounds like the Bible, so we don't want it. But we'll be looking at the Big Bang a little bit more next time, and how that came about as well. So basically, that's the kind of ideas that they had. Hutton firstly, and then Charles Lyell came along, and he thought, right, if I can prove it, if I can get a practical example, then we can basically overturn the Bible's timelines. So what he did was, in 1841, he decided to date the Niagara Falls. And he looked at it for a while, and he thought, based on my calculations, I could see that the falls is eroding back by 1 foot per year. If we extrapolate that back to where it is now, I will then make an assumption that it took 35,000 years for the gorge to wear back as far as that. Therefore, the Bible is wrong. Okay, and a lot of people said, as it says there, many people believe it was Lyell's dishonesty, we'll find out why he was dishonest in a moment, which played a significant role in the abandonment of the biblical timescales. Right, now he made some fundamental flaws in his thinking while he was working this out. And some people might say, the more cynical, might say he did it deliberately. He ignored the locals who had observed it eroding at 3 to 5 feet per year. He said, no, that doesn't fit my calculations, so that cannot be right. He ignored the fact that certain rock layers erode more than others. Basalt, for example, granite would erode a lot slower than limestone. All right? So when it was going through different layers, it would erode at different rates. He ignored the fact that throughout different seasons of the year, the water flow is different. Greater water flow gives greater erosion. And if there was an ice age, as they say, when the ice melted, that would create massive water flows, which would increase the erosion rate enormously. And of course, all this doesn't take into consideration the fact that there could have been, just could have been, a worldwide flood, which would massively alter his entire stance. The other mistake he made was he didn't even actually observe the falls for 1 year. It was much less than a year. I can't find in the literature how long he observed it for. It just says much less than 1 year. So unless you're doing that, you can't see how things are changing as we go through. But this is the foundation then for this different way of thinking called uniformity. Right, so we're starting to look more towards the dating methods now. So what the scientist will do is he'll observe the present state of the rock or system, which is to be dated. A bit like with the potato peeling, the present state is there's potatoes being peeled and they're being dropped in the basket. Then he'll measure the rate of the process presently operating within the system. No problem with that. You see it operating 1 potato per minute, whatever it is, that's science, because you're looking at it in the present and observing it in the present, and it's repeatable, and you can check it, and you can double check it, and it's there, it's observable. So that's what science is, that's the definition of science. But then, they set up some assumptions, and this is where it can start to go horribly wrong, and this is called model building. Right, so we've already alluded to them. The assumptions are the rate of decay has remained constant over time. We're dealing with a closed system, not affected by the environment, and the original ratio was nil. So there was nothing there to start with. The scientist now calculates how long the present process operating through the unobserved past would have taken to produce the state that it currently is in, based on the assumptions. But it's based on the assumptions. And they forget to mention the assumptions. if you see them in the news talking about this or on TV programs, they'll tell you how all these things are. They'll say what dating method they use, but they don't mention the assumptions. Right, so we're going to look at the two main dating methods they use now, and they're used for different things, so it's important to understand both of them. The first one is called radioisotope dating. Excuse me. Now, radioisotope dating is for dating things that are meant to be very, very old. The other method they use, carbon-14 dating, which you've probably heard of, a lot of people assume that that means things are very, very old, but in actual fact, carbon-14 dating is only used for things that are relatively young in comparison. So let's have a look at this. So this measures how one isotope, which is a particular chemical element, decays from one thing to another, and there are many different isotopes. So this is a system within a rock. So it could be, for example, uranium decaying into lead, or it could be argon decaying into potassium. Those are the two of the main ones, but there are many others that they can use as well. And it's very important I use the word decay there, because otherwise a lot of people come along and say, hang on, isn't it evolved? Aren't they evolving from one into the other? And that's proof of chemical evolution. No, it's decay. So it's not getting better, it's actually decaying. Some books say it's actually getting worse. Other books that I've looked at say it's staying the same, but it's certainly not getting better. For it to be evolution, it would have to be progressing, but it's not. It's actually going the other way, if anything at all. The only rocks that can be dated by this method as well are volcanic rocks. So rocks that have been massively hot and then cooled, because it's believed that that heating process resets the clock to zero, because it gets to such a temperature, it resets it, and it starts counting from zero again. So that's that nil ratio. It's called zero reset, that nil ratio that they talk about, and they can start counting. So you can see when a rock was born, it comes out of a volcano, it's born very, very hot, the clock starts ticking from there, and you can start to observe these rates of decay going on within the rock, and therefore you can tell how old the rocks are. It cannot date rocks that are sedimentary. That's an important point, because sedimentary rocks are actually made up of tiny particles of other rocks, and they have tried to do that, but their conclusions have been massively, massively inaccurate, so they've more or less abandoned that at the moment. So that's important. So limestone, for example, is an example of sedimentary rock. So only volcanic rock. You could date a tree caught up in the rock flow. I will see some examples of that a little bit later. You'd use a different dating method for that though. So here's the process. Each time an atom decays into another type of atom, it gives out a certain amount of energy. And you can measure that energy with great accuracy. So that part is good, that part works, it's scientific, and you can measure that rate, it's perfect. So the rate at which uranium, for example, decays into lead is highly measurable and observable in the present, that's science. And then you've got something which you may have heard of called the half-life. It's often mentioned in scientific films, and I say scientific films, science fiction films. The half-life is often mentioned. And that's how long it takes for half the amount of the chemical to decay. So imagine you had 4 ounces of lead, and how long it takes for half of that to decay into uranium. Rather, is that the right way around? No, uranium, sorry. 4 ounces of uranium, half of that to decay into lead, that's your half-life. And then it's a ratio. So half of that is the same time again, half of that's the same time again. And the half-life for this is 4.51 billion years. All right? And then for half of that to decay again is another 4.51 billion years. And they will say that's how we know the world has to be 4.51 billion years old, because we see these half-lives operating. So if we can see it once, then that's at least how old the Earth must be. And when we do carbon-14 dating, I'll show you a graph of how it works so it'll become clear. I know it's quite complicated. Right, now to date the rock, the scientist first has to observe the current state of the rock, which means measuring the amount of effective isotope. Then, once they check the rate, they then do a simple sum, and they say, based on my calculations, given that there is now this much lead in the rock and this much uranium, and originally there would have been all uranium and no lead because the clock was set to zero under great heat, then we know the rate, so we can conclude that the rock is such and such of an age old, so many years old. Right, so that's how it works. All right, it's quite complicated, I know. But this is based on the 3 assumptions. So we're going to look at those now in detail in relation to this kind of dating method, radioisotope dating. So the first assumption, if you remember it, was the rate has remained constant. So is it reasonable to assume that the decay rate has not changed over 4.5 billion year half-life even though we've only been measuring it for the last few decades. Now, originally, the answer to that was yes. It didn't seem to change. It seemed to be a fixed rate. Even atomically, it didn't seem to change. So, most people gave it to the scientists and say, yeah, it's feasible. But then a project came along called the RATE project. And I'll explain more about that a little bit later, but it stands for radioisotopes in the age of the Earth. They actually started to try and test this. And they came up with evidence that the rate may have been different in the past. Best example is this. High levels of helium retention were discovered that indicated that abundant nuclear decay must have occurred recently, otherwise much more helium would have leaked out. So judging by the chemicals that were there, the rate must have been quicker in the past. So has it remained constant? Unlikely. All right, so that's the first assumption. The second assumption, the system has remained isolated from its environment. So this means that it hasn't been affected by anything outside. So is it reasonable to assume then that neither the parent, uranium, nor the daughter, lead concentrations, or any of the intermediate products, some of which are highly mobile gases, by the way, they move from one place to another, have been altered during the entire history of the rock, except by this radioactive decay? Now, this assumption becomes a lot less reasonable because they will fully admit there's a process called leaching, and it could be water leaching or chemical leaching, and if they see any of this happening, they will discard that sample. So if they spot that it's been tampered with or contaminated by this chemical leaching or water leaching, they will discard it, which sounds like a good thing to do. So that should mean the samples they've got left then are clean samples, and you can get some good dating methods from those. But what they do is they only keep the ones that they want to receive. So imagine that they're working with these clean samples, and everything's looking good. Then all of a sudden, maybe one comes up with 4.2 billion years ago, 4.3 billion years ago, and then another one throws up 50,000 years ago. Oh, this must be wrong. Chuck it out the sample. Right? So even though we can't see any problem with it, even though it looks clean, it must be wrong because we know the world is 4.5 billion years old, so we'll chuck it out. So they keep the samples that they want, discard the ones that they don't want. We do that with averages. It's like get rid of the top and the bottom and keep the one in the middle type thing. So if leaching and contamination can occur, this is my question, which cannot be visibly detected, how do we know that they haven't occurred in these clean-looking samples, which are skewing all the data anyway? All right, so if you can't see it's there, how do we know that the ones they're keeping are the correct ones? That's the question. Walter Weiss puts it quite directly. This is from his lecture, The Earth in Time and Space. And he says, question, does lead dissolve in acid rain? Yes, that's why we have heavy metal pollutions in our rivers and in our lakes. So if it rains and water falls on the rocks, and rocks are porous, which they are, and the water goes through, can I wash out some of the elements from the rocks? Yes. Mountains soak up water and form huge reservoirs of water because they soak them up like a sponge. So this is a mechanism for taking out the isotopes. So the question is it really, are these systems really isolated from their environment? Answer is almost certainly, well, definitely, I would say not. Okay, so that's the second assumption. Then the final assumption. This was the one, the original ratio was a nil ratio, so everything started counting from 0 at the beginning. So this assumes that in the beginning there was no lead and just uranium. Is it reasonable to assume that the daughter product had a nil value? Was there no lead in the initial product, so no lead there to start with? If there was some lead in the original rock when it was formed, then it would appear very old because it had lead in it to begin with. Does that make sense? So when the rock was created, perhaps there was lead there anyway. You can't just assume, as it says there, that all the lead came from the uranium. So it would then have a superficial appearance of old age. Okay, now, let's see some actual examples of this operating and see if these assumptions that they've made are indeed true or whether they're in fact false. And there's some quite amazing examples. Okay, have a look at this now. Sunset Crater in northern Arizona. This was formed by a series of volcanic eruptions, and they actually found Indian artifacts in the lava, which tells you there were people there at the time, and they found Indian remains in the lava flow as well. Now, there weren't many deaths. All the people there moved away because basically the lava covered their agricultural sites and their villages, so they moved away. But they took with them an oral tradition that this happened about 950 years ago. Then they used tree ring dating through bits of tree caught up in the lava flow, and this tree ring dated the eruptions to 1065 AD. So two methods showing that this took place around 950 years ago, probably 1065 AD. They then dated the two lava flows using radioisotope dating, and they used a potassium-argon decay method in this case. And this yielded two separate answers or two separate dates of 210,000 and 230,000 years ago that this took place. Yet we know it was in 1065. All right. Let's have a look at another example. This is a coal mine in Queensland. A vertical ventilation shaft had to be built down, and when they were drilling their way down, they encountered a basalt layer, and beneath the basalt layer, which would mean it was older than the basalt layer, they found pieces of unfossilized wood. Then they used carbon dating, which we're going to be looking at a bit later, of the wood, and this yielded a result of between 30,000 and 45,000 years ago. But the basalt layer, using the potassium-argon dating, which should have been older, of course, yielded, or younger even, because it was above the wood, yielded a result of 39 to 57 million years ago. All right, so they've got these dating methods and they're not agreeing with each other at all, even though these things have been found more or less the same place. Big problem, big problem. This one, Mount Rangitoto in New Zealand. Now, the eruption of Mount Rangitoto in New Zealand, it was dated by radiocarbon studies of a destroyed tree to be less than 300 years ago. You can actually date quite accurately with radiocarbon dating with a certain time perimeter, but the further you go back, the more inaccurate it can become. We'll see that later. However, by potassium-argon, it was dated as being 485,000 years ago. Okay? Big problem again. And this one just blows me away, this one. The Hualalai volcano in Hawaii. Now we know historically this erupted in 1800 to 1801, which should then set that clock to zero when the lava flow comes out. There were people living in it at the time. The English, the French, and the Americans are all sailing the world. The ship's logs documented. We know it happened in 1800 to 1801. Then they potassium-argon dated 12 samples of the lava flow, and those samples came back ranging from 140 million years ago to 2.96 billion years ago. Yet we know it happened in 1800 to 1801. So how accurate is this dating method? You decide. Right, okay. Walter Weiss, in his book, The Genesis Conflict, he gives even more examples. But if we look up here, just from here, he says the obvious statement now, that if the clock is not set to zero when a deposit forms, then there could be no starting point from which to calculate the age of the deposit. So the chances are this clock reset hypothesis is wrong. All right? So radioisotope dating has three basic uniformity assumptions, plus there are three more as well. It also assumes there was never a world restructuring flood, which can affect things massively. We're going to see some examples of that coming up when we look at carbon-14 dating. It assumes there was no creation, which you can understand and believe in, because they're meant to be naturalistic, fair enough. And the world is 4.5 billion years old, because that's their half-life. All of these assumptions have to be in place to make the system work, and that is basically its Achilles heel, because if one of those assumptions, just one, is off, then it could throw the results massively. And the chances are all of those assumptions are off. Okay. Right, okay, now then, we're going to move on to carbon-14 dating. Now this is probably the one you've all heard of, because it seems to be mentioned on television all the time, and on documentaries. They often mention carbon-14 dating. And all the same assumptions are there, so we don't need to go over those again, but there is some differences in the way that this works, so I'll take you through that so you can understand it. Right, now, carbon-14 dating is only relevant for relatively recent time periods because the half-life is relatively short. It's only 5,730 years, so it's relatively short. Even the most devoted advocate would note that carbon-14 dating has very little to say beyond about 60,000 years ago. So that's at a stretch. All right. In reality, it's much better for dating things that are a lot younger than that. By 100,000 years, they say carbon-14 would be completely indetectable. But that also means, if you work the other way, that if you find carbon in something, it must be less than 100,000 years old by default. Probably less than 60,000 years old as well, because that's what they're saying, all right? We'll look at some other factors in a moment. Carbon-14 dating is used to date once living things mostly. So things that were once alive, you could date using carbon-14 dating. You can also date things like diamonds as well using it. I'll show you some examples. But this is quite good in terms of looking at the half-life on this table over here. You can see that you've got 5,700 years there. That's the half-life. So if you start off with 1,000 grams of carbon-14, after 5,700 years, you'd only have 500 left. After another 5,700 years, so it takes you to 11,400, you'd only have 250 grams left. After 16,100 years, you'd only have 125, and so on and so on and so on. And they reckon about 100,000 years ago, there'd be none left. That's basically the hypothesis behind it. Right, now, this works a little bit differently, so I'll explain to you kind of how it works. But it's to do with cosmic rays bombarding the upper atmosphere. Now, we all have carbon within us. That's the first thing to note. And there's a certain type of nitrogen-14 that reacts to cosmic ray bombarding. In other words, it reacts to our environment and it decays into radioactive carbon-14. You can see that up here. And it comes down, and then, as you see there, then it produces fast-moving neutrons. These neutrons collide with atmospheric nitrogen atoms, and this produces radioactive carbon-14. And that's what we take in. So, everything in the world that reacts to the solar environment has a ratio of stable carbon. That's normally carbon-12, by the way, best example. And we get an unstable carbon-14, sorry. And we get it from the food we eat, the water we drink, the sunshine we walk around in, and the air we breathe. And the ratio is evident in every single human being or other living organism. So if you look at that diagram at the top there, they say it's currently in what they call equilibrium, the carbon-14. So the amount we take in is the same as the amount we give out. So while we're living, we're taking it in, we're giving it out. We're taking it in, we're giving it out. And it's more or less equal as we go through. Then when we die, the picture at the bottom, we stop taking it in, but we're still giving it out. And then the ratios begin to change. And then that's the ratio, the change that they're looking at in order to calculate the age. So the unstable carbon-14 then starts to revert back. And the ratios begin to change, so they're then different from a living entity. Scientists then calculate how long something has been dead by looking at the rate at which the C14 is no longer in correct ratio to the more stable forms of carbon, like carbon-12. So as we can see here, look at the blue there, the carbon-12 stays constant all the way through. And you can see there's the carbon-14 just here, there it is. And basically, while we're living, it stays constant. At the moment of death, it'll be constant. Then after we die, you can see it getting less and less and less. And that's the rate that they look at. And so after 100,000 years, there'll be absolutely none left. But the more you go back into time, the less accurate it gets, because the less you can actually detect it. Okay, this guy, Dr. Willard Libby, he was the guy who basically came up with this theory. And he's an evolutionist, and he based it on the whole thing about the world being 4.5 billion years old. Now then, one of his claims was that it would have taken 30,000 years for it to reach, this carbon, to reach equilibrium in the first place, which again would shatter the biblical time frame. But it's since been proved that that assumption is incorrect. As it says there, other factors can affect the production rate of carbon-14 in the atmosphere. We're going to look at lots of them now. This is the first one. The Earth has got a magnetic field around it, and this protects us from harmful radiation from outer space. This magnetic field is decaying, it's getting weaker. The stronger the field around the Earth, the fewer number of cosmic rays that are able to reach the atmosphere. This would result in smaller production of carbon-14 in the atmosphere in the Earth's past. So if this was stronger, this field in the past, we'd have less carbon-14 getting through in the first place, and that would affect the results. So the rate is not constant, i.e. the first assumption. So plants and animals that lived on the Earth 4,000 years ago would have had much less carbon-14 because that field was much stronger in the past. The low amount of C14 would make them appear to be thousands of years older than they really are. And we'll look at some examples in a moment. Other considerations. Experiments have been performed and have shown that rates can and do vary. changing the environment surrounding the samples can alter the decay rates. For example, the atomic bomb tested in the 1950s caused a rise in neutrons which increased the carbon-14 concentrations. So that would have affected it as well. And if there was a worldwide flood, we've seen in previous seminars there's quite a lot of evidence for that. Walter Weiss does a whole lecture on this, by the way, called The Worldwide Flood, if you want to check it out. It says the flood would have uprooted and or buried entire forests. Of course it would. This would decrease the release of C12 into the atmosphere through the decay of vegetation. Large amounts of carbon from living organisms would have been buried to form today's fossil fuels. That's where they come from. We'll come back to that later. The amount of fossil fuels indicates there must have been a vastly larger quantity of vegetation in existence prior to the flood than exists today. The fossil record confirms this for us as well. Fossil record shows far more ferns, cycads, all kinds of plants that are no longer in existence today. This means the biosphere prior to the flood might have had 500 times more carbon in living organisms than today. So pre-flood material would be dated at perhaps 10 times the true age. Now that is very interesting when we look at some examples that we've got coming up. Right, going back to the RAPE project, this contained, they did a lot of work around this, contained scientists, all creation scientists, there they are, and there are 8 of them all together. Take a note of this guy, D. Russell Humphreys, because he's coming up a little bit later when we look at something else. But others that tend to come up a lot in other areas, I've seen Vardaman there, Stephen A. Austin there, and Andrew A. Snelling as well. I've done a lot of work all around this. Okay, now, fossilised samples. A series of fossilised wood samples, this is one of the things that they looked at, that conventionally would have been dated according to their host strata, that's the layer of rock they were found in, from Tertiary to Permian, would date them, because they're in that layer, they would say, well, those layers are between 40 million and 250 million years old. Yet they all yielded significant detectable levels of carbon-14, which would equate to only 30,000 to 45,000 years old. Remember, it has to be under 100,000 years anyway, if carbon's in there, for the original trees. Divide that by 10. What do we come up with? 3,000 to 4,500 years old. Biblical time frame. Okay, next one. They looked at coal samples. Okay, then they obtained 10 coal samples from the US Department of Energy Coal Sample Bank from all across the United States. The chosen coal samples, which dated millions to hundreds of millions of years old, based on standard evolution time estimates, all contain measurable amounts of carbon-14, automatically placing them less than 100,000 years old. The average carbon-14 estimated age for all the layers from 3 time periods was approximately 50,000 years old. But remember, a pre-flood C14 C12 ratio reduces that age to about 5,000 years. Biblical time frame again. Diamonds. They also tested some diamonds. And with these diamonds as well, it's important to note that they didn't test them themselves in a way. They sent them to a secular tester to be done. All right? So they haven't rigged the results. The RAPE project analysed 12 diamond samples for possible carbon-14 content. Similar to the coal results, all 12 diamond samples contained detectable but lower, admittedly lower, rates of carbon-14. These findings are powerful evidence that coal and diamonds cannot be the millions of billions of years old that evolutionists claim. So, less than 100,000 years again, which would divide out by 10, less than 10,000 years. None of that takes into consideration what a worldwide flood would have done, though. Other than the whole thing about dividing it by 10, okay? Right, they carbon dated a live mollusk, right? Or a few of them by their shells, and they told us that these live mollusks were 2,300 years old, and they were still alive. They also carbon dated live penguins, and they came out as 8,000 years old. Unlikely, very, very unlikely. Okay, so just to conclude on this particular section, carbon-14 dating, we know it's got a half-life of 5,300 years. It shouldn't be found in samples older than 60,000 years, because that's how far they stretch the validity. Yet we've seen that they're found in coal, they're found in diamonds, they're found in other ancient specimens, but also, significantly, they find them in dinosaur bones as well. When do they tell us that the dinosaurs died out? How long ago was it? 65 million years ago, and yet their bones contain carbon. Not only that, They also contain red blood cells, soft tissue, veins, all perfectly preserved. And they want us to believe that these existed over 65 million years ago. No chemical way. Right. Now then, what's their excuse? They'll say it's a contaminated sample. But the trouble is, all of these are contaminated samples in that case, all of them. So they censor it instead. They don't let you know about them. Okay, so conclusion. All radio dating methods are based on assumptions about events that happened in the past. If the assumptions are accepted as true results, they can be biased towards the desired age, as we've seen. In the reported ages given in textbooks and other journals, these evolutionary assumptions have not been questioned, while results inconsistent with long ages have been censored. When the assumptions were evaluated and shown faulty, the results supported the biblical account of a global flood and a young Earth. Walter Weiss puts it fairly bluntly as well in his lecture, The Earth in Time and Space. He says, so, I cannot guarantee that the rate of decay has been the same. I cannot guarantee that the clock was set to 0 when the material was formed, because it's not set to 0 even today, and I'm not dealing with a closed system. So how good is my clock? Frankly, my clock is useless. Totally useless. The scientific method of determining one isotope relative to the other may be perfect. That may be so, but it means nothing in the light of these points. Right, so with this second half then, we've looked at the dating methods now, and we've seen that they don't really work because of the assumptions that they're based on. Because basically they're assuming that all the potatoes were being peeled at the same time, they're assuming that no potatoes were being removed or taken away from the basket, and they're assuming that there were no potatoes in the basket at the beginning, if you go back to our parable that we started with. Right, now, even if they admit that there are problems, probably the best you'd get them to admit would be to say, well, we admit that the dating systems aren't perfect, but they're the best we've got to work with, so that's what we go with until something else comes along. That's probably the best. Most of them wouldn't even admit that. But they will also say, you're out of order anyway, you're bang out of order in what you're saying, because there are many, many other evidences for a young Earth. For example, if we look at the rock stratas in the geological column which nowhere exists in the world, by the way, in the form that they put it in the textbooks, they just got one bit here, one bit there, and they just put it all together as if it existed, but it doesn't. All right, so that's important to bear in mind. But they say those strata, those rocks, the solid rock, those would take millions of years to turn into solid rock. Well, here we have some doorknobs, and they are encased in solid rock. 300 million year old solid rock. So now we have a choice. Either these doorknobs are 300 million years old, or this rock is not 300 million years old. Another example. This is a ship's bottle from the HMS Birkenhead, which sank off Danger Point in South Africa in 1852. So we know how old the bottle is. So now we've got another choice. Either this bottle is millions of years old, or that rock is not millions of years old. Another example, a ship's bell encased in solid rock. All right, so now we have a third choice. Either this bell is millions of years old, or this rock is not millions of years old.
Coral,
Sorry?
It's coral stuff, is it actually rock?
It is actually rock, yeah, definitely. I've double-checked it, yeah. But, you know, good to raise the point though, yeah. Okay, now then, stalagmites and stalactites. Right, now, if you've been to some of the caves, the caves in Cheddar, for example, or the caves in Wookey Hole, how old do they tell you the stalagmites and stalactites are? How long do they take to form? Millions and millions of years. Okay, now then, this stalagmite, which is grown and joined together with the stalactite and stalagmite joined together, was in a basement. And this building was 40 years old when this picture was taken. So what does this say about the claim of great ages for cave formations? Does it take millions of years for these things to form? This is another one in Queensland in Australia, stalagmites and stalactites. The mine was 55 years old when the picture was taken. Yet we're supposed to believe it takes millions of years for these things to form. Walter Weiss, in his lecture again, The Earth in Time and Space, says that there's a bridge he drives under to work every morning, and there's a stalactite hanging from that about so long. You can see him showing how long it is there. And every time he drives under that bridge, he thinks, wow, who erected this millions of years old bridge over here? There's one last hope, gemstone. Okay, now surely that takes millions of years to form. It forms similarly to stalagmites and stalactites, hence you can see the columns going on there, and this is malachite. And this is expensive stuff here because it's believed to have magical powers. Witch doctors in South Africa use it, and in their rituals, so it's believed to have magical powers and charms to it as well. And some of it was shipped over from a dealer to America, but it broke in transit, and they sent it back. And then the dealer had it, and he called Walter Weiss, whom he happened to know, and he said, I've had this amazing piece of malachite come back that's broken, you should come over and have a look at it. So he went over and had a look at it, and inside, you can't see it very well in this picture, but it was right in the middle about there. There's some copper wire inside the actual rock, which tells us that copper wire must be millions of years old, or that this rock does not take millions of years to form. The other option is that the people at the mine worked out that having copper wires down in the mine helps the rock to form even quicker, so then they can harvest it quicker, they can get it quicker, yield it quicker, and sell it and make more money. Right, so Walter Weiss was with this guy, and he said, so what are you going to do? And he said, well, I'm going to have to give this guy a refund. And he said, how much did it cost? $26,000 for 12 by 12 centimetres. So he said, well, why don't you just get some more off the supplier and say, oh, he said, I called them, but they said they're all out. So he said, well, that's a good opportunity. Phone them up and ask them how long it would take to find some more. So he phoned them up, and they said, no, we're all out. He said, yeah, well, how long will it take to find some more? He said, well, how big do you want it? He said, okay, how big do we want it? So Walter Weiss was in the background saying, same size, same size. So they said, okay, we'll have the same size, 12 centimetres by 12 centimetres. We'll have the same size. So he said to the supplier, how long would it take to find that? And he said, oh, we should be able to find that in about 3 months. So how long does this stuff take to form? Millions of years? Maybe not. Right, now, another piece of evidence, which we saw right at the beginning of that quote, was that ice proves that the world is millions and millions and millions of years old. That guy in that article said 5 million years old, or 500 million years old, long time anyway. Now then, what they'll say is that the ice in the world will prove definitely, beyond the shadow of a doubt, that the world is at least 100,000 years old. That's in reality what the scientists will tell you. Now then, they do that by drilling into the ice, and they basically pull out a column of ice. And in the column of ice, you can see hundreds and hundreds of rings, dark light, dark light, dark light. You can kind of see them on that picture over there. That's what we're looking at, is these rings going down. And they say that each of those rings represents 1 year, because when it warms up in the spring, one of those rings is created, and then the following year another one's created, following year another one's created. Then, during the war, there were some planes that landed, and they crash landed in Greenland, and this was in 1942. And then by 1988, they decided they were going to go and look for them because they had the kind of equipment needed to detect where they were. All right, so they decided, they located them, and they decided then to dig down to them. And as they dug down, that's the picture of what they're actually doing there, they noticed these ice rings, and there were thousands and thousands and thousands of these rings all the way down, which must mean that these planes have been buried for thousands and thousands of years, right? Or there's another option. These rings are not annual rings at all. They just simply mean hot, cold, hot, cold, hot, cold, and it can warm up and get cold many, many times in a season. There's another lecturer called Chad Cruiser on the Amazing Discoveries website who does carbon dating, a lecture on that. And he shows 1 week's snowfall in Canada, where he's from, and there are 6 or 7 of these rings in 1 week's snowfall. All right, so maybe this evidence isn't quite so reliable. The other thing that they could say is when they go to the lakes, there's something very similar on the edge of the lakes called varves. And those are annual rings as well, and there's thousands of those also. But just like the rings, these ice rings, the varves are caused by a change of wind direction, change of temperature. Vav. Change of wind direction, Vav, and it all the way down. Walter Weiss has a photograph of a leaf in 45 Vavs all the way down. We've got to admit that's a pretty resilient leaf to wait 45 years to be buried in those Vavs. Okay, now we've got that out of the way, this is a question that's seriously thrown at creationists all the time. One of the main allegations thrown against them is that how on earth then can we see stars if they're millions and millions of light years away, if the Earth is an old Earth? Or rather, if the Earth is a young Earth, how can we see them? It must be old. So, I haven't seen many people tackle this, but on the Amazing Discoveries website there was an article that I looked at, and then I found another guy, a lecturer in America, a science teacher, giving a lecture on this as well. So we'll share some views from that, and then you can make up your own minds. So there's 3 things to consider when answering the starlight question. Number 1, scientists cannot measure distances beyond 100 light years accurately. So no one can measure star distance accurately. Scientists measure star distances using parallax trigonometry. The furthest accurate distance they can measure is 20 to 100 light years, depending on which textbook you read, not several billion light years. 0.5 million light years away is impossible to figure with trigonometry. Right, now this works by working out angles. So basically they look at the way the solar works, and they work out the 2 furthest angles apart, which would be June and December. They can pinpoint those angles in space, or those points in space, quite accurately. Then they try to work out from those accurate points a point much further away. Now that's the equivalent, basically, of 2 people standing, and they'd be standing 16 inches apart, and if they try to work out from that narrow angle a point 824 miles away, that would be the equivalent of trying to work out a point 100 light years away. Alright, so you can imagine how massively inaccurate that would become after a short distance. If you're then trying to work out millions and millions and millions and millions, it's going to become a lot less accurate. Okay, the other thing is they can use methods like luminosity, so they're looking at the brightness, and also the red shift as well, which is the whole stretching of light, giving that red shift. We'll look at more of that next time, because we're going to look at the Big Bang. But these are employed to try and guess at greater distances. But all of these methods do have serious problems because they're based on assumptions. So they can get so far accurately, and then you have to assume. And we've seen the problems with that so far. Right, now, second point, no one knows what light is, or that it always travels the same speed throughout all time, space, and matter. So light does vary in different media, hence the rainbow effect of light going through a prism, and also may vary in different places in space. Now this is some work carried out by somebody called Dr. Li Zhang Wang of the NEC Research Institute in Princeton. And he did some research into this whole speed of light. And he came up with this, interesting quote here. Scientists claim they've broken the ultimate speed barrier, the speed of light. In research carried out in the United States, particle physicists have shown that light pulses can be accelerated up to 300 times the normal velocity of 186,000 miles per second. So that's the first thing, it does vary massively. Right, now, in the Bible, Genesis 2 verse 2, it says, "Thus the heavens and the earth were finished, and all the hosts of them." So everything was created mature. Alright, so Adam was full grown, the trees had fruit on them, the starlight was visible, everything was completed. It wasn't that God created the stars and thought, right, I've got to wait 10 billion years now for the light to get to Earth. Now, that's a bit of a hypothesis. How can that work? Can it work scientifically? The answer to that we're going to look at in a moment. But 17 times in the Bible, it says that God made the stretching process happen. Here's 3 examples. So Isaiah 45:12, "I have made the earth and created man upon it. I, even my hands, have stretched out the heavens, and all their hosts I have commanded." Job 26:7, "He stretcheth out the north over the empty space, and hungeth the earth upon nothing." Now, at the time, a lot of people said that's a ridiculous thing to say. How can the earth possibly be hung on nothing? The Romans and the Greeks believed that Atlas was holding the earth up. The Hindu cultures believed that the earth was resting on an elephant, which was resting on a turtle. Didn't say what the turtle was resting on, mind. Right, okay? So it was found to be ridiculous. But now we know that that's actually true. The earth is resting on nothing, so the Bible's got it quite right. Isaiah 44:24. Thus said the Lord, thy Redeemer, and he hath formed thee from the womb. I am the Lord that makes all things, that stretcheth forth the heavens alone, that spreadeth abroad the earth by myself. So again, the stretching is referred to. Another 14 times in the Bible, especially in the Old Testament, that's referred to. You can look it up. Right, now then, guy comes along, D. Russell Humphreys. He was part of the rape project that we saw earlier, and he really went to town into looking into this. And he was looking to construct a theory that was biblically sound, but more importantly, scientifically sound. Now then, first thing he was saying is, this is highly simplified version, mine. If Einstein's E equals mc squared is true, nuclear energy should work. Gravity should bend light. Black holes are possible, and if you stretch the fabric of space, you stretch space-time. That's the most important point. If God has created the universe by stretching it out, then time would be stretched with the space, and on the edges, it would be stretched more than at the centre, where we probably are. Scientific research lately has shown that the galaxy that we're in is pretty close to the centre of the universe, and that's what he's saying there. So, Dr. D. Russell Humphreys, he's a reputable creation scientist, made the calculation that if space was stretched out that much, time would be stretched enough that the stars would appear in our sky while 4 Earth days passed here, but at the same time, billions of years could pass at the edge of the known universe because of that whole stretching process. So, very, very simplified, this is how it would work. You've got a white hole, which is drawing things away. Black holes draw things in, white holes draw things out. We're here, the white hole's drawing things out to the edge of the space, that when God gets the white hole or the edge of the universe to where he wants it, it starts to come back in. And there's something called an event horizon, which when it starts to come back, it will draw things back in with it. It's a bit like if you watch the water going down a plug hole, within a certain radius, it will bring everything down the plug hole with it. So within a certain radius of the black hole, everything comes back. So it comes back, and it would be dragging the light with it, and then shoom, it goes past our Earth, all the stars light up at the same time, and that would take 4 Earth days to accomplish. What day does the Bible say that the stars and the moon were created in the Bible? Any ideas? Day 4. Okay. Now then, so that's that, all right? There's a lot more to talk about with that as well. We'll be coming back to it a little bit more next time. I'm going to finish off now, before we do the devotional part, with other evidence for a young Earth. So the decay of Earth's magnetic field. The Earth's magnetic field is decaying at a given rate, which points conclusively to a young age for the Earth. It appears to be a fixed rate, so if you use their assumptions, you come back to a date of 8,700 years at the top end of the scale for when the magnetic field in the Earth's atmosphere first kicked into action. But it could be as little as 4,000 BC, which would place the Earth at 6,000 years old. The quantity of helium in the Earth's atmosphere. Helium is escaping from the Earth's atmosphere because of radioactive degeneration, and helium is coming into the Earth's atmosphere as a result of the same process. The rates are measured, consistent, and show no evidence of change, and again, when we extrapolate these back, it arrives at a young age for the Earth at 6,000 years. The breakup of the cluster galaxies. Now, there's 2 types of galaxies. You've got field galaxies and you've got cluster galaxies. 80 to 90% of field galaxies do not have sufficient gravitational mass to hold them together. So eventually the gravity breaks up and then they go off and become field galaxies on their own. So that's what it's saying there. They estimate this process of taking 2 to 3 million years. So if the Earth is 4.5 billion years old and the universe is 13.8 billion years old, as they say, there should be hundreds of field galaxies in the universe. Not one has been found. They've spent years looking for one little, if we can just find one little field galaxy that will prove this to be true. They haven't found one as yet. The rate at which red giant stars turn to white stars. Sirius, for example, was recorded as a red giant star by many observers 2,000 years ago. Today, it's a white dwarf. They thought this process from red stars to white stars took millions of years, but this one has gone from red to white in the last 2,000 years at most. Young Earth. The rate at which some moons' magnetic fields are disintegrating. So this suggests a hot core, and that means that if the hot cores are millions or billions of years old, they would have cooled a long time ago, but they're still hot. This indicates a young universe, or by default, a young Earth. Oil pressure. The amount of oil pressure found in the underground oil fields means that oil fields must be less than 10,000 years old, otherwise the pressure would have equalised. We saw that rock is porous, so it's escaping all the time. The fact that it's still bubbling down there tells me not long ago. And as noted earlier, oil, tar and coal are evidence for the flood, because that's all organic, all this is. Organic materials rapidly buried become these fossil fuels. And then just very quickly, the moon is moving away from the Earth at a set rate, applies to young Earth. Spiral arms of galaxies, these deteriorate at a given rate, but the fact that they're still there indicate a young age for the Earth. They're spiraling around. If they spiral around 10 times, they work out that it would just morph into each other, so they wouldn't be visible anymore. The fact that they're still there shows that it hasn't been happening for long. The rate at which comets disappear, young Earth. The absence of novas and supernovas. Novas are explosions on stars, supernovas are explosions of stars, young Earth. The rate at which some planets are losing heat, young Earth. Oh, this has stopped working now. Let's move on. Yeah. Saturn rings are unstable and therefore cannot be very old. That indicates a young universe, and by default, a young Earth. Right, so there are millions, well, hundreds, I should say, of these evidences for a young Earth. There's one guy, Dr. Don Batten, if you want to Google it, he does 101 evidences for a young Earth. And he put it up on the internet, and then some evolutionists came along and tried to debunk it all. And it's basically using quite a lot of swearing and a lot of inference and conjecture, so things you can't go and check. So, for example, with the whole thing about the oil, they said that the amount of rock on top of the oil would be the equivalent of 3 inches of steel thick, which would last millions of years. But there's no way of going to check that, of course. It's theoretical, it's a hypothesis. And a lot of the ways that they put these answers together, they might sound good to the untrained ear or the untrained eye, but when you know how their minds work and what the assumptions are all based on, you can pretty much debunk them. And Dr. Don Batten wrote a response to it as well. And in some ways, they hadn't even read his whole article, because he wasn't, in his article, he wasn't proving that the Earth is 6,000 years old, he was just proving their dating methods are wrong. But they were saying, well, this doesn't prove it's 6,000 years old anyway. It proves that it's 60,000 years old. Well, that's still a lot less than 4.51 billion years. Now, all this science and the proving is all great, but the most important thing is, of course, that our relationship with God is right. So, whilst I find this very fascinating, and it's something I'm deeply interested in, what is of huge significance is to make sure our relationship with God is right. And our relationship with God comes through this book over here. This book here. Right? This is the most important thing. And it's very important that we stick to God's word. I think that's probably the most important thing. With the Bible, of course, it does refer back to the creation process many times, so I love it when it does that. If we look at Acts 17, for example, the scenario here is that Paul is defending himself in front of the Areopagus and in Athens. And it's pretty remarkable what he achieves in this speech. It still stands today as one of the greatest oratory highlights of any era of mankind. It's quite remarkable. But if we look at verse 24, it says, God, who made the world and everything in it, since he is Lord of heaven and earth, does not dwell in temples made with hands. And he has made for one blood every nation of man to dwell on all the face of the earth, and has determined their pre-appointed times and the boundaries of their dwellings. So, we didn't come from some slimy process. God created us, not only as individuals, but as a species. And he determined when we'll come into existence, and also when we'll go out of existence as well, when he comes back. Okay, then if we look at verse 31, God has fixed a day in which he will judge the world in righteousness through a man, capital M, whom he has appointed, having furnished proof to all men by raising him from the dead. And I think that should come up there. No, it doesn't. But Mark chapter 9, verse 42 tells us one of the greatest allegations against us can be if we cause a little one to stumble. So it's our job, part of our duty, to teach people the truth. All right? So that's really, really important. We can cause little ones to stumble because we taught them nonsense, basically. We taught them doctrines of man. We taught them things that have nothing to do with eternal values. And ultimately, that can be a huge stumbling block for them. So what we need to do is to hold on to this word here, get out there and tell people that this book, from start to finish, is right. Always has been, always will be right. And if we want to start putting question marks after the first few books of Genesis, then logic dictates we might as well put question marks after the whole Bible. Why not? It's either inspired by God from the first verse to the last verse, or it's not. That's the end of it. Okay? And we've seen these doctrines of man. Are they on firm foundations, or are the foundations based on sand? It looks like foundations based on sand to me. Falls down when it's subjected to scrutiny. All right? But the Bible stands true, always has done, always will do. That's the really important thing. Okay, now then, if you want to find out more, these references are on the sheet over there as well. But Walter Weiss, The Earth in Time and Space, that's where he looks at those rocks and how old they are. There's a lot more examples than that as well. They actually found a miner's hat encased in solid stone, by the way, solid stone from a mine, and that was vacated only 30 years ago. Teddy bears in the caves in Yorkshire. People go there, put teddy bears, the water's trickling onto them, come back 1 year later, they are solid stone. Okay? So there are plenty of other examples as well. Chad Cruz here, dating methods, fascinating. He does it very simply as well, so you can really get into it straight away. And this guy here, Dr. G. Charles Jackson, he's the science teacher in America, and he does the session Starlight and the Young Earth, which explains about that theory about the young Earth, plus many other examples. He does a brilliant one called Death of Darwinism as well, and it's also very, very funny. All right, so I'd recommend you listen to that. And there's the book as well, John Smith, the Young Earth book as well. Okay, on we go. Right, okay, that's all for this session. This is all part of spiritual warfare, right? This is the last point I wanted to make. We need to remember that in the end, Jesus has got the victory, all right? And we find out about Jesus in here. And he has the victory at the end of the day. This is all part of spiritual warfare. If you've read Ellen G. White's book, The Great Controversy, you can see how it all maps out there. It's all raging at the moment. We're in the last days now. And last time I alluded to how Freemasonry actually brought evolution to the forefront and championed it as well. Because, I didn't tell you the reason then, but I'm going to tell you now. If we're evolving, we keep getting higher and higher and higher. And eventually, we're going to evolve into what? Gods. The devil's lie in Genesis, all right? You will become like God. God says, no, you will die, all right? One of them's lying. We know which one it is. This is all part of that agenda. And now, transhumanism has taken that agenda forward as well, because if we can use technology to speed up that process, then we're going to become like gods much sooner. All right? So this is one of the reasons why evolution was championed in the first place, because it fulfills that agenda nicely. And there's some fantastic lectures by Walter Weiss, and he'll set it all out exactly how it happens. All right? If you look at his Total Onslaught series, especially 20 to 30, there's 36 of them altogether, but 20 to 30 explains it all perfectly, how that agenda works, and how he'll actually go back 100, 150 years and show how they're all planning it as well. The writings of Alice A. Bailey, people like that, all putting it, this is what we need to do in order to bring this about, and it'll happen. Blavatsky, another one as well. You know, Blavatsky, she said that Lucifer was God, the Son of God. Jesus was not. And she is the person honoured by the United Nations. Her writings are honoured by the United Nations. Right? We honour the Bible and the writings of Ellen G. White, okay, which say that Jesus is the Son of God, the true Son of God. So, you know, I've made my choice. I'm sure you've made yours as well. That's, you know, this is what the bottom line is. And Jesus has the victory at the end of the day. All right, on that note, shall we have a quick word of prayer? Okay, dear Lord, thank you so much for bringing us here today. Thank you for this time of sharing, this time of analysing, and this time of scrutinising as well. And I pray it's been a blessing on the people here today. And that from this day forward, Lord, that we will not be confused or led astray by the doctrines of man. And from this day forward, we make it about your word alone, Lord. In the name of Jesus, we ask it. Amen.